thing. Two polygons are similar if all corresponding angles are congruent and corresponding sides are proportional. This right here is a similar symbol. Okay? Similar symbol, it looks like a congruent symbol without an equal sign. Just one little mark. Okay? We're going to talk today about if two polygons are similar, then they'll have a similarity ratio. Okay, the similarity ratio is the ratio of the corresponding sides. Sometimes they will tell you to compare the blue figure to the red figure, or compare the big figure to the small figure. If they do that, then you have to have it the right direction. You have to be specific in how you write your similarity ratio. But if they just say, here's two figures, what's the similarity ratio? Then it's up to you to decide. And I might say 2 to 3, and Jet might say 3 to 2. Okay, and we would both be right if they didn't tell us which way to go. Okay? Any questions on the two parts or facts that go along with the polygons? They're similar. Okay? So here we have an example of a couple triangles. And we're told that the three angles of triangle ABC are congruent to the three angles of triangle EDF. That means these triangles have to be similar. Okay? If one of those two facts is true, then they're both true. So these two triangles have to be similar. I'll pause while you copy this stuff. All right, here we go again. This statement right here tells us that the two triangles have to be similar because all the angles of triangle ABC are congruent to all the angles of triangle DEF. Okay? And they're matching them up in order for us. A matches up with B with D. B matches up with E. And C matches up with F. Sometimes the triangles or the polygons, whatever shape they give you, will not be matched, will not be lined up exactly the same. Sometimes they'll be flipped around, rotated, reversed, upside down, whatever. Okay, so you have to make sure that you identify what matches up with what. Okay? If they had told me that triangle ABC is similar to triangle DEF, then here they're telling us that these match up. Okay? The order in which they write that statement is just as important as the order in which we would write a congruent statement. Okay, and you've done that a bunch of times already. So understand that. If they give you a statement like this, they're saying that those angles match up in the order in which they write the statement. Okay? So let's go back to the picture. So since A matches up with D and B matches up with E, then AB is going to match up with DE. I don't want to put a little line there to imply they're equal. They're not equal, they're proportional. Okay? So my similarity ratio, if I choose to go big to small, well, what's the length of the big side? 6. And the length of the small side? 4.5. Okay? Now if they ask for the similarity ratio, and just the similarity ratio, that's another problem with what was written up there. It said similar ratio. It's not the proper term for it. It's the similarity ratio, or it's the ratio of similarity. Okay? Depending on which book you use, they might name it a little differently, but usually it's one of those two terms or phrases. If they ask for the similarity ratio, you would want to reduce this. So 6 over 4.5 reduces to, well, 1.5 goes into 4.5 3 times, it goes into 6 4 times. So if I divide top and bottom by 1.5, I get 4 over 3. Okay? Now, another way of looking at that, you might say, well, how do I know? I didn't see that 1.5 went into there. So remember, if you multiply the bottom, let's go up here, we have some room. You multiply the bottom by 10, you get 45, don't you? And 45 now is a whole number instead of a decimal, right? So if we multiply the top by 10, I get 60. And probably all of you would see a 5 would go into there 12 and 9 times. And a 3 would go into there 4 and 3 times. So if you have a decimal and you don't see how it reduces, don't be afraid to multiply by 10 or 100 or whatever it takes to get rid of the decimal. Okay? Then reduce it the way you're more familiar with. All right? Any questions on that? So that's my similarity ratio. Now, if they want me to find x, I didn't really need to find the similarity ratio to find x. This out of the way. I could have started with my ratio big to small. 6 over 4.5 is equal to, now what did I put on top? The big triangle or the small triangle? The big. So when I compare the other ratio, I have to go big to small. Nick might have said, well, I want to go small to big. That's fine, but on the second one, you have to do the same. Small to big. You have to go in the same direction. If I go 6 to 4.5, then I have to go 10.6 to x. You don't have to find this in simplest terms and use that here. You can just use the numbers they give you. Okay? But sometimes they'll ask for both. They'll ask for the similarity ratio, then they'll ask you to find the variable. Okay? So 6x is going to equal 10.6 times 4.5. If I divide both sides by 6, x is equal to, what is it?
7.95.
Any questions on how we found that? Just a second, let me pause. So here we have a couple trapezoids. I should say just quadrilaterals. I guess there's no markings indicating the bottom two, or the bottom and the top are parallel. There's nothing like that indicating that. So we have a couple quadrilaterals, and we're told they're similar. Okay? So the question is, what is angle T congruent to? Angle T. What is true here? Oh, TKA? Okay, or K, since we're saying this one's congruent to this one, right? Since it's the only angle at that intersection, it's okay to just use a single letter. I can't do that here. I can't call this angle Q because I don't know if I mean this angle or the straight angle. Okay, there's too much going on there, so I can't do that. Okay? What goes in there? KK? Kai.
I'm misunderstood.
I know, I'm sorry. What did you say? KA?
No,
US? USA. Us goes in there, yes. Right, us goes in there. Okay, we're saying that this side is to this side just as this side is to this side. They're the corresponding. If I look at the statement KA and QU, it's going to match up with AP and US. So you see, from that similarity statement, I could do the same thing. I don't need the picture if I'm really good at it. But if I'm not really good at it, I haven't seen a lot of it yet, then I have to be a little careful and probably should draw pictures to look at. Okay? So we said US goes in here. Okay? TQ to TK is equal to bless you. What goes in there? You want to see the top? TS? Do you agree, Caleb? You don't like my S?
I love it.
You mocking my S? You're calling it a G?
Yeah, I'll take it too. It's a bit G-ish.
It's a bit small G-ish. Everything here is a capital letter. How about that S? Is that better?
Yeah, still looks like a 2.
No, it doesn't.
Once he said
What
it,
planet are you on? You might say it looks like a 5, but you can't say it looks like a 2.
Yeah, it's not that.
Are you in the mirror?
You can say it, it doesn't mean his
All right.
It's the closest thing it looks to is if you flip it around.
All right, any other questions on this?
No.
All right, you getting the idea how to find corresponding parts?
Yeah.
How the sides are proportional? Okay? Matching them up the proper order. If I go big to small on the first one, I have to go big to small on the second one. If I go small to big on the first one, I have to go small to big on the second one. Okay? Alright, and the angles are always congruent. They're not proportional, they're congruent. Angles are congruent. Okay? Go ahead and copy that down. So 1.618 to 1 means the length of the long side is 1.618. The length of the short side of the rectangle is 1. Okay? As I started to say, we're not going to do a whole lot with this. I just want you to be aware of it, that there is such a thing as a golden ratio. Okay? Golden rectangle. It's not the same as the golden rule. Not quite as important as the golden rule, right, Jeff? Right. But in math, we are forced to look at it. And what's special about it is we can keep breaking this rectangle up. The green rectangle we can break up into break that rectangle up into a square and a rectangle. And we can break that one up into a square and a rectangle. When I say a square and a rectangle, is anybody not seeing the square I'm talking about? Yeah, Caleb?
Does the golden ratio apply to anything else except golden rectangles?
No. Well, no. I mean, there might be other things that you probably won't run into in math where they say the golden rectangle, the golden ratio applies to this, or it's the same as the golden ratio, but
We won't do those.
no. We're really not going to do much at all with this today other than just be made aware of it. And I think there's one or two examples that have you use it, but it'll be the same as the others. As far as, they're just giving you the numbers 1.618 to 1, okay? But I want to go back at this again. The big rectangle was cut into this square and this rectangle, okay? And then we took that rectangle right here and we cut it into this square and this rectangle. Then we took this rectangle and cut it into this square and this rectangle. And we can continue to do that as long as we want to make it smaller and smaller and smaller. As you can see, I took this rectangle then and cut it into this square and this rectangle. And I can do the same again now with this rectangle. Cut it into a square and a rectangle. Every one of them will have the same ratio, 1.618 to 1. Okay? They'll have the same ratio then. That won't be the lengths of their sides anymore. Their sides got smaller and smaller and smaller, right? But they're going to have the same ratio of the long side to the short side. They're all going to be the same as this ratio right here. Okay? That's what makes this the golden rectangle. We keep breaking it up into squares and rectangles. They're all going to have the same ratio. Okay? Any questions on this? All right. Let me pause for a second. So in this problem, we're looking at a map, and this is our scale. 1 inch equals 40 miles, so how many miles is 1 1/8 inches? And so we can make our ratio this way if we want. We have inches on top, miles on the bottom. Okay? Number 2 in yesterday's homework converted to inches. Had 185 feet, and we had 6 inches. The model was 6 inches high, and the actual tower was 185 feet high, the Tower of Pisa. Okay? And they converted to inches. There's really no reason to do that. I'm not sure why they did that. It's not like we were comparing a photograph that was 2 feet wide and 1.5 feet high, and we had 18 inches high and 2 feet wide, where they're different units to the same picture. That's different. I agree that we should convert to the same unit. But in a scale, like we have here, a scale on a map, we don't want to convert 40 miles to inches. Multiply 40 times 5,280 just to get it to feet, and then multiply it again by 12 to get it to inches. We don't want to deal with those gigantic numbers. Okay, and it's not necessary. So we're going to keep this inches to miles. We just have to make sure that every ratio we write if we choose to go inches to mile, is in the form of inches over miles. And so we have 1 inch over 40 miles, and we have 1 1/8 inches over X miles. So 1X then is going to equal 40, so 4, times 9/8. Would you agree that 1 1/8, 8 times 1 is 8, plus 1 is 9, so we get 9/8, okay? How many times does 8 go to 40? 5. And 8 once, what's 5 times 9? 45. Okay?
I figured out how many inches that was.
Okay. Good. So 45 miles is how many inches?
2,534,400.
Okay, good. Now you memorize that and you'll be all set.
I just already
Okay. I think you agree with me that we don't want to be converting miles to inches. We want to stick with our scale. It's just really important that you don't mix them up. I can't go 1 over 40, which is inches over miles, then over here say X over 1 1/8, which was miles over inches. If you flip them around, it's not going to work. Okay? You have to stay consistent in what you're attempting to do. Any questions on this scale? All right, I think that's it. Our assignment. I want to look at the calendar with you for a moment. If you look at your calendar, the fact that we didn't have a nice day or cold day today was good for a calendar, because you see on Monday we have lesson 8.5 and lesson 8.6. Okay? The reason I'm doing that is because I don't want to end up with not enough days here. Oops. I don't want to end up on the 13th, 14th, and 15th with not enough days to prepare for your exam. You'll also see there's no quizzes for this chapter. You'll also see that there's no Chapter 8 test. Every one of your tests have been cumulative all along, so Chapter 8 test in your exam would look nearly identical anyway. So your Chapter 8 test is your final exam. You guys will take your exam on Friday, the 16th. And so our final assignments will be on Monday. I will not be here on Monday. Mr. Faust, you know, the guy who observed my classroom, he'll be here, and he'll be going, the whole math department will be working with him all day that day. So I'll be in and out, but I won't be in here teaching. So what I'm going to do is sometime later this week, I'm going to put the notes to 8.5 and 8.6 online. Okay, and then you can show them in class for all those who don't have internet at home. But if you have internet at home, you can do it over the weekend if you want, and get your notes done and work on whatever homework you want to work on. And then come in Monday, and all you'll have to do is finish up your assignment so that you're not behind. Okay? That is the reason I've decided I do want to collect your homework every day starting tomorrow. I said no to some people yesterday, so I wasn't going to change my mind on them. I didn't think that was fair. Had they not asked, I just surprised you, that's one thing. But some people asked yesterday, and I said no. So I'm not going to lie to them and change my mind. So we didn't collect homework today, but we will the rest of the week. Make sure that you get this. Do you want me to record your question? Or?
No, I was